Hi, 8th graders. In this lesson titled Jack and Jill Went Up the Hill, we're going to use similar triangles to describe the steepness of a line. We're going to talk about rate of change between any 2 points on a line, and we're going to explore the steepness of a line, eventually getting to some other types of equations besides y equals mx or y equals kx that we saw in the previous lesson. So for our warm-up, I would like for you to try this on your own. I've defined coefficients and constants. So coefficient is the number multiplied or attached to a variable, and a constant is a number without a variable. No variable, just a number is called a constant. So I'd like for you to pause the video and try this warm-up on your own. All right, let's go through answers here. So what I'm going to do is for the coefficients, I'm going to mark them in red. I'm going to underline them in red. So 64 is the coefficient in number 1. -8 is the coefficient in number 2. This minus sign tells us that this next term is negative. -3 is a coefficient. +18 is also a coefficient. Number 4, 42, and 27 are both coefficients. 27 is positive because of that plus sign. So just to recap, coefficient 64 for number 1. -8 for number 2. -3 and +18 for number 3. And number 4, we have 42 and +27. Let's use purple to underline the constants. So that'd be 24, 36, no constant in number 3. In number 4, it would be -1. So constant would be 24. Number 2, the constant is 36. For number 3, there are no constants. And for number 4, -1. That subtraction sign tells us that term is negative. So now let's jump into our getting started for this lesson. So here's some similar triangles. We're going to compare a ratio for each one of these and then eventually connect that to the steepness. So we're going to write a ratio that represents the relationship between the height and the base. So we're going to write this ratio as height over base. So for this first one, the height is 10. The base is 10, so that would be 10 over 10. For figure B, the height is 15. Base is 4. Figure C, height 15, base 15. And figure D, height 12, base 3. For the second part of this, we're going to take each one of those ratios and write them as a unit rate. So we had 10 over 10, we had 15 over 4, we had 15 over 15, and we had 12 over 3. So unit rate means we want the denominator to equal 1. In order for the denominator to equal 1 here, we would divide both of these by the denominator, which gives us 1 over 1, or just 1 for figure A. Divide by the denominator here to get 1 down here. 15 divided by 4 is 3.75, so unit rate would be 3.75 for figure B. Divide by the denominator here. You get 1 over 1, or just 1 for the unit rate for C. And for figure D, divide by the denominator. You'll get 4 over 1, or just 4 for the unit rate for figure D. How can you use these rates to compare the steepness of the triangle? So again, this unit rate was 1. For B, it was 3.75. For C, it was also 1. And for D, it was 4. So if I'm just looking at this, well, I notice that figure A and C have the same unit rate. Figures A and C have the same unit rate. And it looks like they have the same steepness too. I can also tell that the steepest ones are B and D. And actually, if I look a little closer, based on the figure and the unit rate, it looks like figure D is the steepest. So the one with the bigger unit rate is the steepest. Figure D is the steepest. Figure D also has the highest unit rate. And that's a wrap for the warm up and the getting started. I hope that this helped identify ratios, turn them into unit rates, and then connect that unit rate and those ratios to the steepness of triangles. We're going to build on that throughout this upcoming lesson. Have a great day, everyone.